Imagine you're holding a miniature version of our planet. You can see mountains, rivers, and even cities, all laid out before you. That's what a map is, a visual representation of the Earth's surface. Maps are essential tools for understanding our world. They help us navigate, explore, and learn about different places. Maps show us where things are located in relation to one another. They are like puzzles, piecing together the different parts of our planet. Maps have been used for centuries by explorers, sailors, and travelers. Ancient civilizations drew maps on clay tablets and animal skins. Today, we have advanced technology like GPS and satellite imagery to create highly detailed maps. Whether simple or complex, maps help us make sense of the world around us. Just like there are different types of stories, there are different types of maps. Each type serves a specific purpose. The three main types of maps are physical, political, and thematic maps. Physical maps show us the natural features of the Earth. They highlight landforms like mountains, valleys, and deserts. They also depict bodies of water like oceans, lakes, and rivers. Political maps, on the other hand, focus on boundaries. They show the borders between countries, states, and cities. These maps help us understand political divisions and relationships. Thematic maps tell a specific story about a place. They use colors, symbols, and data to represent various themes. For example, a thematic map might show population density, climate patterns, or natural resources. Maps have their own language, just like any other form of communication. Understanding this language helps us unlock the information they hold. Three key components of map language are distance, direction, and symbols. Distance on a map is represented using scale. Scale tells us the relationship between the distance on a map and the actual distance on Earth. For example, a scale of 1 to 100,000 means that 1 centimeter on the map represents 100,000 centimeters, or 1 kilometer in reality. Direction is usually indicated by a compass rose. This symbol shows the 4 cardinal directions: north, south, east, and west. It helps us orient ourselves and understand the relative positions of different locations. Symbols are used to represent different features on a map. For instance, a triangle might represent a mountain, a blue line a river, and a star a capital city. Maps usually have a legend or key that explains the meaning of these symbols. Imagine you're baking a cake and need to reduce a recipe. You would use a scale to adjust the ingredients proportionally. Similarly, map scale helps us visualize the vastness of Earth on a smaller surface. Let's say you're looking at a map with a scale of 1 to 10,000. This means that every unit of measurement on the map, like an inch or a centimeter, represents 10,000 of those same units on the ground. So if 2 points on the map are 1 inch apart, the actual distance between those points in the real world is 10,000 inches, or about 833 feet. Map scale allows us to understand distances and plan routes, whether we're exploring a city or planning a road trip. Just like every house has a unique address, every point on Earth has a unique set of coordinates. Coordinates are like a special code that pinpoints any location on our planet. We use a system called latitude and longitude to define these coordinates. Latitude lines run horizontally around the Earth, parallel to the equator. Longitude lines, on the other hand, run vertically from the North Pole to the South Pole. By knowing a location's latitude and longitude, we can pinpoint its exact position on a map or globe. This system is essential for navigation, mapping, and even for tracking the movements of satellites and airplanes. We live on a sphere, a round planet, but maps are flat. How do we translate the curved surface of the Earth onto a flat piece of paper? This is where map projections come in. Think of a map projection like peeling an orange and trying to flatten the peel. You can't do it perfectly without stretching or tearing some parts. Similarly, map projections use mathematical formulas to transfer the Earth's surface onto a flat plane. Different map projections have different strengths and weaknesses. Some preserve shapes accurately, while others prioritize area or distance. Understanding map projections helps us choose the best map for a particular purpose and interpret the information it presents. Latitude plays a crucial role in determining a region's climate. The Earth is tilted on its axis, which means that different parts of the planet receive varying amounts of sunlight throughout the year. The equator, located at 0 degrees latitude, receives the most direct sunlight and therefore experiences warm temperatures year-round. As you move further away from the equator towards the poles, the angle of sunlight becomes more oblique. This means that regions at higher latitudes receive less direct sunlight and experience cooler temperatures. Latitude is a key factor in understanding why different parts of the world have different climates, from the tropics to the polar regions.